Oh, today we're going to talk about matter, how to describe matter. So there are two properties that chemists use to describe matter. The first one is physical properties. Physical properties are characteristics that describe matter. They include characteristics such as size, shape, color, mass, and so on. An example of physical properties is magnetic property of iron. And you can see in this experiment, iron dust was poured on a sheet of paper and a magnet was placed under the paper. And after, you will see that iron dust is located along the lines of the magnetic field. Can you see this? Yes, so that is one of physical property of iron, magnetic property. So what is chemical property? Chemical property is something that describes how matter reacts, how it changes its chemical structure or composition. An example of chemical property is flammability, for example, and materials' ability to burn, because burning, also known as combustion, changes the chemical composition of a material. In this experiment, you can see that preheated iron wire placed into an oxygen and it can burn very well. This is an example of the chemical properties of iron. Right? So to describe matter, we can use physical properties and chemical properties. Okay. Okay, so elements and compounds. What are they and what is the difference between them? So any sample of matter that has the same physical and chemical properties throughout the sample is called a substance, right? So let's say sodium chloride, known as a table salt, is a substance. So, what kind of properties has sodium chloride? The sodium chloride very easily soluble in water, right? So they are white crystals which do not have an odor but have a taste, right? In its aqueous state, sodium chloride acts as a good conductor of electricity. So it has a melting point at 800 degrees by Celsius, and these are physical properties of table salt, sodium chloride, right? So, and in this experiment, you can see how sodium chloride is forming a solution with water, right? So because it's easily soluble in water. So all these properties, what I was mentioned right now, these are physical properties, right? Yeah, and you can see amount of visible sodium chloride become smaller and smaller, and now we have a solution. So sodium chloride mixed with water, but we do not know and we can not see that there is a sodium chloride inside the water, right? But what about chemical properties? Chemical properties of sodium chloride, we can tell that sodium chloride reacts with silver nitrate. And you know, this is double displacement reaction. Two soluble substances react with precipitate being formed here, right? So silver chloride is insoluble, and as you can see there, this is a white color of silver chloride. So yes, this is one of chemical properties of sodium chloride. So it can react with something. So these are again two kind of way to describe a substance: physical properties and chemical properties. Okay, the next one, sodium metal. The next example of substance is sodium metal. So physical properties of sodium metal are: sodium is a silver white metal, very soft, easily cut with a knife, and you will see it in this experiment. A fresh cut of sodium glistens. Density less than 1, so density is uh, less than density of water. That's why sodium floating, right? Melting point is about 100 degrees in Celsius. But chemical properties: as a very active metal, it can react with water. So small pieces of sodium was added to the water. And you can see it reacts with water very violently. A piece of sodium placed in water flows. Due to the heat released, it melts, turning into a white ball that quickly moves in different directions on the surface of the water. The reaction proceeds with the release of hydrogen, which can ignite. And this is an example of a chemical property of sodium metal, right? So again, physical and chemical properties describe substance. So there are two types of substances: a substance that cannot be broken down into chemically simpler components is an element. And this kind of substance has there only one type of atoms inside. So, like oxygen gas, or let's say chlorine gas, or nitrogen gas, or hydrogen gas. These are elements. Sometimes we can add pure elements, but it's not necessarily to do this, right? It is very rare to find meet a pure element around us, but sometimes or some of them exist as a pure element, like aluminum, which is used in soda cans, is an element or a pure element too, right? So we can write it down, aluminum. Okay. A substance that can be broken down into chemically simpler components because it has more than one element is a compound, right? So compound, like water, like CO2, like HCl, so like table salt, right? So NaCl. So these are compounds. Today there are about 118 elements in the known universe, and all these elements you can find in periodic table. But scientists have identified tens of millions of different compounds for now. So the smallest part of an element that maintains the identity of that element is called an atom. And you already know how atom is built, right? So, and you know that noble gases exist as atoms, or not wanted with each other, but some uh, substances has atoms inside, the same atoms inside, and they bonded with each other, like diamonds are composed of atoms. So, molecules are composed of atoms that are attached together and behave as a unit. So, to have a molecular structure, you need to have covalent bond. So, you need to be a covalent substance, right? So HCl, this is a covalent compound, so it has molecules H2O covalent to CO2 covalent, but NaCl, this is ionic compound. So it is built out of ions, not from molecules. So, but these are molecular. But they are compound together. Why? Because they are built of more than one type of element. Thus, substances with unique physical and chemical properties can be pure elements or compounds. Mixtures, and we can see here mixture and mixture, homogeneous or heterogeneous mixture. So what are mixtures? Mixtures are materials composed of two or more substances. In a mixture, the individual substances maintain their chemical identities. Many mixtures are obvious combination of two or more substances, like here. We can see here a mixture of sand, iron, and table salt, and you can see that it's obvious combination of many substances, right? And you can see now we separate iron using magnet, because each substance, each compound or each element in a mixture has its unique properties. Okay, so such mixtures in which we can see that it is built out of two or more compounds or substances are called heterogeneous mixtures. But what is homogeneous mixtures? Homogeneous mixtures will be if in this water we add, let's say, sodium chloride or sugar and mix them together. By this way, we will have homogeneous mixture. Only after testing we can tell, is it like pure water, or is it salted water, or is it sweet water, right? So mixture about which we cannot tell, are they just have one compound or two or more, called homogeneous mixture. So phases. Another way to classify matter is to describe it as a solid, a liquid, or a gas, which was done in the examples of solutions. These three descriptions, each implying that the matter has certain physical properties, represent the three phases of matter: solid, liquid, and gas. A solid phase has a definite shape and a definite volume. Liquid have a definite volume, but not a definite shape. Usually, a liquid takes the shape of their containers. Gases have neither a definite shape nor a definite volume, and they expand to fill their containers. So we encounter matter in each phase every day. In fact, we regularly encounter water in all three phases: ice, solid phase of water; water is liquid phase of water; and steam is gas. So substances can change from one phase to another if the conditions are right. Typically, varying the temperature of a substance, and less commonly the pressure, can cause a phase change. So phase changes have particular names depending on what phases are involved. So to change phase from solid to liquid, you need to melt something. So it's melting or fusion. From solid to gas is sublimation. From liquid to gas is boiling or evaporation. And you did evaporation the last time during your lab. From liquid to solid, it's freezing. From gas to liquid, it's condensation. From gas to solid, it's deposition. So, and we will continue to talk about the properties of mixtures, such as, for example, solutions, homogeneous mixtures, about the characteristics of solutions over the course of several classes.